All right, we're beginning the recording of our Masterclass International. Welcome to all the participants that are signing in right now. This is our second of two webinars this week. We held one in Italian on Tuesday, and this is our webinar in English. And it's a partnership between Italy and the United States as part of one of the big goals of international collaboration for Polar Educators International. Today, the topic is climate change, science, and communication, and we have our speakers ready to go from Bird Polar and Climate Research Center over at Ohio University. We have Dr. Paolo Gabrielli and Jason Cervenek, and today's Thursday, the 25th of February, 2016. And I'm going to move our slides ahead. If you have any trouble seeing the slides moving, please feel free to type into the chat box or your questions panel, whichever is visible to you as participants. Your controls there's many different controls and they may look a little different to you on your screen, but please feel free to ask questions in the chat or questions box. At the end of the presentation, we hope to have time for live questions, and we'll open up the microphones at that time. There is no video today in our presentation, so don't worry if you don't have a video showing on your screen, but we do have our slides. And yes, participant microphones will be muted during the presentation, but feel free if you do have questions during the presentation to type them in and we will relay them to our presenters. We'd like to thank one of our partners, Climate and Cryosphere, or CLIC, for being a partner that allows us to use the GoToWebinar system. So thanks to them for that. Just a very quick note about Polar Educators International. This group was formed about 4 years ago, hearing the need of teachers and educators around the world that have become quite passionate and enthusiastic about sharing polar science with their students. This came about during the International Polar Year, and the momentum has continued to build. PEI is a vibrant network promoting polar education and research to a global community. We have over 1,000 members around the world, and not only are they in the polar regions, but in countries like Italy, Portugal, and other places that have strong polar ties. You can reach us at our website at polareducator.org. There's a really active Facebook group, Polar Educators International. That's what you would search for. Please join us there and contribute to the conversation. And our secretariat or host institution at the moment is the Arctic Research Consortium of the United States. So we thank them as well. Just a quick note on the certification of participation. This is offered to teachers or attendees in Italy and the United States. Emails have been sent out to folks who indicated that they were interested in that partnership and participation. So if you have not received an email from me, this is Sarah Bartholow, pairing you up with one other attendee to have a conversation, please let me know if you are interested. Feel free to email the organizers. And what we're doing is just offering the opportunity for more dialogue after this presentation. So those who are seeking certification are paired up with another person, and within 10 days of the webinars, the teams must work together to schedule a conversation, a virtual conversation through Skype or other technology with one another to talk about the content, and then submit one-page summary of the discussion to the Masterclass International organizers. It's a really simple process, and it's the opportunity for you to share the value of Polar Educator International work with your colleagues. And there will be a post survey for those doing the participation as well. So what I'll do right now is turn it over to our speakers, and Paolo is first. Are you ready to go, Paolo?
Yes, I'm ready. Thank you, Sarah.
Wonderful. On my end, you seem a little quiet. Is there a way that you could sit closer to the microphone, perhaps?
All right, is it going better now?
Let's see. I hear you a little bit better. If any participants are not able to hear, just type in your chat box and I'll relay that. But I think it sounds okay for now.
All right. Thank you very much, Sarah, and thank you also to Polar Educator International for giving us this possibility tonight to reach many interested people in our activities. So, good evening, everyone. I'd like to speak tonight about ice cores as a climate window into the past. And we are speaking from the Bird Polar and Climate Research Center in Columbus, Ohio, where we work with ice cores and in paleoclimate and in paleoenvironmental reconstructions. Next, please. And so I'd like to start my presentation introducing the home of the ice, Greenland and Antarctica, because traditionally these have been the places where first ice cores were extracted. And here it was possible to extract cores of a length of 2 miles, going back almost 1 million of years in the case of Antarctica. But the specialty of the group of paleoclimatology here at the Bird Polar and Climate Research Center is to extract cores from low latitude, so from the highest glaciers around the world. And here in this slide, we can see 3 locations that we have recently visited. Mount Ortles in Italy in 2011. Northward Glacier in Papua New Guinea in 2010, and Volcan in the Cordillera Blanca in South America. Next, please. Here we have a map that shows the position of the drilling sites for retrieving ice cores around the world. As you can see, there is a concentration of drilling sites in Greenland, in the Arctic, and in Antarctica. There are much fewer possibilities at lower latitude, and so I'm going to emphasize how it is important to couple ice cores to other paleoclimatic archives in order to have a correct paleoclimatic and paleoenvironmental reconstruction. Tonight, I'm going to illustrate, in particular, the case of Quelcaya, which is in South America. Next, please. So our group started visiting this drilling site in the late 70s, thanks to Lonnie Thompson, which is our responsible here at the Bird Polar and Climate Research Center. At that time, the Quelcaya ice cap was reachable only by means of horses and donkeys that were transporting equipment and logistics for several days. Today, we can reach the Quelcaya ice cap almost by car. Here on the right side, you can see how the margins of the Quelcaya ice cap appear in the past. So on this ice cap, as also on other glaciers on Earth, snow deposit year by year in layers. And these layers are well evident here in these pictures. You can see in particular some clear bands and some dusty bands, indicating the alternation of wet season with a lot of snow events and dry season with much less amount of precipitations in terms of snow and a higher deposition of dust of atmospheric origin. Next, please.
And we did have a question come in very quickly, if you don't mind me interrupting. What was the difference between the pink and red data in this slide?
So in this case, the difference is just to highlight polar drilling sites from low latitude drilling sites. Another difference is that all the pink drilling sites were visited by the researchers of the Bird Polar and Climate Research Center, while the other red spots are drilling sites that were visited by other groups from around the world, the Europeans, Americans, and also scientists from Asia.
Thank you so much. I'll jump forward to your next slide.
All right. So in this slide, I like to compare ice layers from polar regions and low latitude regions. So something that is striking is how polar ice layers are thin because of the very small snow accumulation that occurs typically in these very cold regions. This allows these glaciers to record very long histories because more layers are offered in a given space of ice, and histories that are long but with a low time resolution. On the right, we can see again the ice layers from the Celtic ice cap. In this case, layers are thicker and allowing the possibilities to have a much higher time resolution, much more detail, but telling shorter histories than those recorded in the polar ice caps. Next, please. So in this slide, finally, we see an ice core. So an ice core is an ice sample of a length that is variable between, let's say, 10 and 3 kilometers. Is a cylinder of ice with a diameter of typically 3-4 inches, 10-12 centimeters. In ice cores, we can observe properties that are visible, such as, for instance, the alternance of wet and dry deposition and the net accumulation, which is indicated by the parameter C in this slide. More parameters are not visible, and instruments and very sophisticated technology is needed to extract more information from ice cores using chemistry and physics, in particular physical and chemical analysis. So we can extract from ice cores many different parameters that are called proxies. Proxies is a word indicating that we are able to read in our ice cores information that are related in relation with the past atmosphere, the past environment, and the past climate. We can extract information in this way in terms of temperatures, measuring the ratios of stable isotopes, for instance, atmospheric chemistry, measuring dust, trace elements, measure ions, again, net accumulation, dustiness of the atmosphere, vegetation changes thanks to measurements of pollens, volcanic history, observing ash tephra layers, anthropogenic emissions, analyzing lead, copper, and zinc, and we can even find entrapped microorganisms in ice cores. Next. So in this slide, I like to illustrate one section of the Kelkaya ice core, and in particular the one comprised between 95 and 99 meters of depth. On the graph on the left, you can observe two proxies, stable isotopes ratios and dust concentrations. Somehow these proxies mimic exactly what we were observing visually, the nice annual layers that were displayed at the margin of the Kelkaya ice cap. Each peak and low record 1 year of climate and environmental histories. In this way, counting annual layers from the top down, we are able to reconstruct the time scale of this ice core, which is reported in the graph on the right. Here, something that you can observe is that the relationship between time and depth is not linear at all. In other words, the half of the history of this ice cap is basically contained in the lower sixth of this quarter. And why is this? So we can understand this looking at the next slide. Next, please. So in all ice caps around the world, we observe a thinning of the ice layers due to compression, but also to horizontal flow. In this context, we lose somehow some resolution or the ability to observe specifically the single years in this case, but we increase our possibility to go back into the past. If you observe the position of this section in our time scale, this is almost at the interface between the bedrock and the ice, and is one of the oldest section of the Quelcaia ice core. Next. So once that we have established the relation between time scale and depth, we can substitute the age to the depth. And this is the overall graph that we obtain, where we can plot stable isotopes and dust concentrations in terms of age, or year in this case. So in this way, we can see variations of temperature as a first approximation, and dustiness of the atmosphere. So climate was variable in Quelcaia, and we could observe different climatic periods. The medieval warming period, about thousands of years ago, where temperature were a little bit high and dust variability was low. And we can see also the Little Ice Age that occurred between something like 400 and 100 years ago, where we have much larger climatic variability, both in terms of temperature than in terms of dustiness of the atmosphere. At this point, we have obtained one record from Quelcaia that we would like to compare and combine with other records. It is what we can observe in the next slide, please, where we compare a composite of the ice core records in the bottom part of this graph in green, and a tree-ring record in blue, and an instrumental record in red in the upper panel. As you can observe, the instrumental record is just a very small part of this history. And this is the real gain of using paleoclimatic archives that allow us to go further back in the past, observing climate and environment at the time that instruments had not been invented and were not available. Still, the instrumental part is very important to calibrate our paleoclimatic archives. And as you can see, there is a rather good agreement between instrumental measurement and tree rings, and also the ice core signal in this case, that show an unprecedented enrichment in terms of stable isotopes, and so in terms of temperature, during the recent time when compared to the last 2,000 years. This is the well-known global warming. Next, please. Yeah, next slide. So, in summary, I would like to stress the role of glacier in the Earth system. Glaciers interact with climate, ecosystems, and human society. glaciers interact with these three components of the Earth system, exchanging mass and energy. For instance, a glacier receives snow and reflect solar light in terms of albedo. Again, glaciers discharge water and provide an important resource both to ecosystems and the human society. And the ecosystem impact glacier, providing particles like pollens and dust that deposit to these glaciers. And of course, most recently, during our current Anthropocene, the epoch of the humans, we have started to pollute the atmosphere, and we have impacted basically all the glaciers around the world with pollutants such as heavy metals and many organic compounds. Next one. So, in conclusions, what are the most important messages? Ice core record our climatic environmental history that can be precisely dated. We determine proxies that are linked to the composition of the past atmosphere. And information extracted in ice core can finally be compared with instrumental data, historical information, and proxies from other paleoenvironmental archives. And next one. And so here I conclude my presentation. I remain available for questions now or later. Just want to highlight that I provide information about our study in ice core, the cryosphere, in general about climatic and environmental change through my Twitter and Facebook account, and you can find me easily, and typically I answer to everyone. Thank you very much.
Thank you so much. That was wonderful. And next, we're going to turn over our speakership to Jason, and he's going to give us a chance to understand a little bit more about the communication side of climate change information.
Okay. So thank you for having me this evening. It's a pleasure to be speaking with everyone. So my name is Jason Serbanek. I'm the Education Outreach Director for the Bird, Polar, and Climate Research Center at Ohio State. And I also work with the team here under the direction of Dr. Brian Mark, who's the state climatologist for Ohio. There's a team of 6 of us, and climate change communication is one of the areas we focus on. Just in this first slide, we do have a website with a lot of our outreach materials. The center has a lot of media from polar regions. We post that onto the website in addition to instructional videos and lessons. And then there's also Facebook and Twitter for those of you that are following social media. And people can feel free to email me follow-up questions if we don't get to all those this evening. Next slide. So just an overview of what I'm going to speak about this evening. I'll give a brief introduction of myself and my background. I'll speak about the outreach activities of the center, just give you a highlight of some of the stuff that we do here and the audiences we work with. I'll go briefly over some places that I think are the first sources to check out for climate change information, things that are well vetted, and to give you an overview of what's happening. After that, we'll discuss some educational resources and places to go to look for materials for your classroom or your informal education setting. Others that maybe just help you have dinner time conversation with relatives over holidays. There's a lot of informal educational opportunities that aren't just educators taking part in programs in classrooms, museums, zoos. And then we'll follow up. If there's questions throughout, I'll be happy to entertain those. So next slide. So a little bit of background about me. I have worked at the center here for about 3.5 years. In the top left photo, I really like being in the outdoors, so that's just one of the draws to come to work at the center here at Ohio State. Most people here really enjoy being outside. My background's actually as a K-12 educator. I was a high school science teacher, so that's the bottom right photograph, for a little over a decade in a public high school that's located in the Columbus area. And I was fortunate as that experience as a teacher to have coached a Science Olympiad team, worked with the theater department, and taught a wide range of different content. I also traveled to India on a Fulbright exchange, so the photo that's in the upper right. And I think that was before I came to work at the Bird Center, but it was the one defining moment that made a lot of the data we work with, and a lot of the statistics that I read every day about climate change a little more grounded, because I saw the here and now of large populations living close to the coasts, in slums, inland areas that were already suffering from drought and water tables that were dropping. And so things became a little more tangible when you see the statistics and how it affects people on the ground. I also like to show a picture of my daughter in the upper panel there. I think for those of us that have young children, climate change, the impact and the way it will change the world has brought a bit more of immediacy, looking at how the world will be with our own children when they grow up and our grandchildren. And in the bottom left panel is just a picture of one of the video clips we've done at the center. We've really pushed into doing a lot of multimedia and getting things into formats that are more accessible for a wide audience. Next slide. So on this slide, I provided an overview of some of the outreach programs that our center does. We do offer tours of our facility, public tours. We have school groups that come through, senior citizen organizations, garden clubs. We have a lot of faith communities. A lot of churches come through our center. You can see in the picture in the center top there, that's actually Cardinal Peter Turkson, who's a member of the Vatican, and he was here on a visit recently to speak at Ohio State. And so we try to work with a wide range of audiences and make sure we customize that experience to what the individual group wants to see. We also send speakers out throughout the country to talk on topics that could be schools, garden clubs, groups. A lot of the interactive things that we create, you can see at the bottom center, some students taking part in an activity here at Bird Center. We also go out to schools and do those. The goal is always to get good instructional materials and good content into teachers' classrooms and show them ways to do the earth sciences with strong pedagogy and accurate content. We also have exhibits. We've worked to set up an exhibit at the Columbus Zoo and Aquarium. We've worked with our science center. In the bottom left, you'll see a picture at our library on campus where we had a large exhibit that had about 2,000 people come through this fall, featuring a lot of the work that our teams are doing in polar regions and some of the history and the archival collection that we have. And then we also produce multimedia as part of that. And you see a picture on the right of a feature film we've done that hopefully will be getting picked up by some of the film festival circuit with some of the bird footage from the 1930s. And in the upper right, we have rock boxes that go out free to educators throughout the country as part of our Polar Rock Repository, including instructional materials free of charge. Next slide. And here's some of the statistics over the last few years. The programs we have reached 182 people last year, or 182 events last year, with about 10,500 people. One of the things is we've become very successful here, and capacity starts to get taxed as you have more and more requests. We see ourselves as one of the places that people call the state for climate change information. Our services are in very high demand, and we have a very wide audience that we end up reaching. So to use time effectively, I won't dwell on this too much, so we'll go on to the next slide, and we'll kind of dive right into the climate change education. Two documents that I think are really important for people to peruse. And I'll kind of stress through this talk that it's important to talk not just about the science content, but really the nature of science and how scientific information is created and there's consensus reached by the community. I started with these two documents because a lot of individuals don't have a chance to see the black box of what's going on in science. Many educators haven't worked in a science facility or maybe don't see science day to day. And I think it's easy to lose sight that it's not just a collection of facts in a textbook. So I'd like to stress to people the IPCC report, the National Academies, the climate change and evidence and causes, because I think if you look at the background of how these documents are created, it's easy to show how robust they are. That the IPCC report, 6 years, 209 lead authors. Just to flip to the appendix in that document is 50-some pages long. And when we go out to schools and work with them, that really is a defining moment for students when they see how large the appendix there and how many authors contributed to it, and how many governments are able to approve that document. The National Academies, it's interesting to think of the history of Abraham Lincoln setting that up as a voluntary group to answer difficult questions for the government. individuals working free of charge, electing one another, electing the next generation of scientists, and how many Nobel Prize winners are there. These are both, especially the climate change evidence and causes, is a very readable document written in a question and answer format. It gives you the answers to many of the questions you'll have in your classroom. The IPCC report is very thick, but I would stress to people the executive summary is the place you should start with. And there's wonderful graphs for those that are looking at ways to infuse data into your science classroom. There are excellent graphs there that help teachers and drill down and have students make sense of what the regional impact is on their part of the world. Next slide. As far as understanding stuff on a national level, it's important to bring things as local as you can. The third National Climate Assessment was released by the U.S. in 2014. It's shown at the website at the top, nca2014.climatechange.gov. That's the first place I would recommend people look after you've been able to look at the previous documents to give yourself kind of a 10,000-foot view. This was designed to be a very media-rich site that is designed to be used as a web platform to review information. That being said, there is a downloads page where you can download either moderate, medium size or very short summaries for what your area of the country, how it's going to be impacted by climate change. You can also go ahead and download summaries by sector, for example, what the agricultural community will see. For our researchers here and anybody doing outreach, one of the things we always take on the road is we download the Midwest section so we can share with Ohioans what things are going to look like here in the Midwest. And then if there's specific disciplines, for example, we went with a farm science review in the state where there's 125,000 people, mostly from the farming community that come, we also bring that agricultural impact sheet. Below that, you'll see the toolkit.climate.gov. This is the U.S. Climate Resilience Toolkit. NOAA is hosting that toolkit. There are two wonderful things about this, and it takes some time to explore, just like the National Climate Assessment. One of those are case studies looking at different sectors and how climate change will impact those sectors. The other is there is a Climate Explorer, which is an interactive map where you can look at things like flooding issues, sea level rise, the impact of various pollutants, connections to public health. And it's designed as a GIS interface. You can go ahead and interact with it, have layers appear and disappear, and then drill down to look at the data that was fed into that. The toolkit is really a resource made up of other resources from federal agencies. We could take an entire, and NOAA's taken entire webinars to speak about it, but it's a great place to allow students to explore data and actually for practitioners and planners to use as well. The data is research grade, and it's robust enough to use for that. For those in your classrooms who are doing things informal environments, sometimes you'll have various questions come up again and again and again from the denial industry. This is a concerted effort. There is actually money behind individuals promulgating misconceptions about and disinformation about climate change. Skeptical science is a combination or a collaboration of journalists and scientists that provide immediate answers to those questions. You will see that letters to the editor responses seem to go out across the country from the denial industry, and this site has very quick rebuttals. There are the short answer, the medium answer, the long answer. They go ahead and they have a thermometer on the left, you can see there with the screenshot showing you kind of the 10 common things that are being promulgated right now. But if you want good fact-check data that you can respond to things, that's the first site I would recommend checking out. Another great site to give you accurate, up-to-date information about climate-related phenomenon is the Capitol's Weather Gang at the Washington Post. Their website is there. They keep a real good beat on what's happening. The Guardian is another site that has excellent information if you're looking for things happening in real time. Next slide. For the educators, if you're looking for lessons, things you can use in class that have been vetted by both scientists for scientific accuracy and also by educators for being appropriate content level, pedagogically sound, the clean collection is probably the gold standard. There's a lot of individuals that have invested significant time into making sure the information there is accurate and timely. Clean is actually a combination not just climate lessons, climate change information, but also of energy. And so if you think about it, and depending on your background, you can think about this for different lengths of time, but the climate energy connection is very strong. It's important to speak about both of those. That is the first place I check whenever we're going out into the field to work with a group that we don't have something we've already developed to use. If for no other reason, you might not take stuff off the shelf, but there's a lot of things that are adaptable. CERC is another excellent resource, similar to CLEAN. It's well vetted, peer reviewed. This is for the earth sciences, so it's not just specific to climate and energy, but anything in the geosciences or the earth sciences. And the last one on this screen maybe comes as a surprise to a lot of individuals. Teaching Argument Writing. It's a book that I would highly recommend, and the reason is I would disagree that a lot of the misunderstanding of climate change is due just to content knowledge. And I say that because there's been a number of excellent articles written recently. March 2015, the National Geographic wrote an excellent piece called "Why Do Many Reasonable People Doubt Science?" There's other articles that have been written over the last 2 years. There's a lot of denial in the scientific community, and you hear things crop up like junk science. And a lot of this stems from the inability of students and the lack of focus on being able to glean accurate information, to construct an argument with evidence, to use warrants. A lot of the things we would have taught previously in a rhetoric course. And while argument writing sounds like you're writing an argument or you're creating a debate in the classroom, it's really not. It's a line of reasoning and creating a system of reasoning. The reason I stress this is that we've been working with English teachers in our region to help get better understanding into their English classrooms for how students think. This came about through the Common Core, and one of the things you'll see with the Common Core is there's a focus on reasoning that sits above all disciplines, not just social studies, science, or English, but it binds them together. As we've gone to classrooms, we've seen a lot of students that are very impressed by teaching them how to look at a site for validity, who wrote the site, where it's hosted, something that in previous generations editors would have done when they published a book. Students have been very savvy at gleaning information from sources, and how they would construct information from different sources to make a well-reasoned argument. I think if you look at the debates happening on the political arena, you'll see that that form of argument is not the argument we really want to have happening in classrooms. It's good, well-reasoned discussion. And I think if you're willing to extend yourself a little bit, or you're here from maybe a different discipline outside the sciences, I would strongly encourage you to be looking at that book for how it can work across disciplines in your school or your setting. Next slide. So in summary of this portion of my talk, a few critical components to regardless of your audience, regardless of what you're trying to communicate, where the setting is, these are 5 things that are well known from the research community and climate change communication you want to include. You want to make sure the audience understands climate change is happening. We're currently experiencing the effects. This is not something we're going to just experience in the future, but they're happening here and now. Make it very clear that humans are the cause, and the scientific evidence for that is overwhelming. We have more than 97.5% of scientists in the atmospheric science community agree this is happening, and that there's something we can do about it. There's also a lot of research who don't want to dwell on negatives. That tends to turn off audiences. While we know there's a lot of really challenging issues to confront, we want to end on a note of there's optimism, there are things you can do, actions you can take. And that's what I'll close on tonight. Next slide.
And Jason, if I can interrupt, this is Sarah again, and we've got a good question here, if you don't mind.
Mm-hmm.
So Betsy Wilkenang, she's in Arizona, and she says, I'm in a class with a bunch of teachers who are listening to University of Arizona scientists in a series of 6 public lectures on climate change. A lot of teachers are frustrated because their students just don't care. It's easy for them to be lazy or ignore it. How do we get students to care? That kind of fits with what you were just saying.
I think that's actually one of the biggest challenges right now. I think we've been doing some surveying data informally at the university, and I think the younger generation now accepts it's happening, generally agrees it's happening, there's scientific consensus. We can help them learn more. I think the gold standard in environmental education is getting changes in attitudes and focus on initiative to do something. That isn't always as easy. One of the things I would stress is getting local involvement on local issues that affect people. is probably the best thing to do, especially with millennials. A lot of, at least at the university level, we see a lot of students interested in doing things to help others, things that involve them taking initiative, but it only works if it's something local you can get your hands on, whether it's getting food pantries, the school to grow food for a food pantry for a vulnerable community, better understanding what water resources are hitting your community and why the more frequent rainfall events, how they're affecting populations and what could be done is probably the most important thing you can do to try to get through that apathy. I would say that's probably one thing I don't have a good guide on. Ideally, it'd be something you could do through multiple disciplines at the school, not just the science classroom. But I think that's actually a challenge in a lot of environments right now is how do you get through the apathy? And I think it's making it as real world as possible, making it as local as possible.
Yeah, and in the background here, folks are saying that yes, the local angle is a great one. And I'll let you continue. And there's a sort of another point or added question in there too is how to engage students effectively into it. So kind of if you want to sort of keep touching on sort of how do we really engage our students? If you want to move to the next slide and keep talking, that'd be great.
Yeah. So a few ways that we've gone about this is you have to think really carefully about your audience and where they start out. We found that chasing ice has been a very effective way to do that. We had the director that was here of the movie, and as he was touring it, they actually made smaller versions, clips that were 11 minutes, 20 minutes, things you could use in classrooms, kind of a teaser to begin the conversation, and that for a lot of the places we go, that's the way to start out. So there's kind of a uniform experience, something that's visually captivating. ICE is not something that has a political agenda, so it's a good place to begin that aren't just graphs and data tables. So it's really, really important. For those of you that are having events with schools, we ask a lot of pointed questions up front when people come here of what content, what level of student, what do they hope to get out of the experience, and then we try different things each time to see what's more effective. And when schools leave, try to get feedback from them on what the experience was like, what they learned, what they still have questions about, to try to successively improve upon stuff visit to visit. Next slide. Realize that for most of the teachers, and there's a wonderful article in Science that came out last week, Climate Confusion Amongst U.S. Teachers, that I'd recommend reading. It's only a 2-page article, but it provides a good starting point for discussing this in the classroom. Most science teachers don't realize that there's 97% or more agreement amongst the climate scientists. I think here analogies always help out. If you had 97% of engineers that said a bridge would fall apart when you drove over it, would you drive over that bridge? Or who would you seek out for advice if you had cancer? Would you seek out anyone, or would you seek out doctors and medical professionals? And if 97% of those medical professionals recommended a course of action, would you follow the course of action for the 97% or the 3%? And I think trying to come up with analogies that are here and now that people can identify with are helpful. Visual graphics like this one shown here are a nice way to do that, to get a sense of how many people. There's actually one of the late night shows that took this and ran with a video segment doing the same thing. One of the things you want to try not to do is offend your audience, and that to get them to not shut down immediately. And so that's always something that's maybe learned over successive years as you try different things in your setting. Next slide. Another thing is, what big ideas do you want to convey? There's limited time, and the information you have to focus on what you feel is most important. One of the things we try to make sure all the researchers here focus on is the distinction between weather and climate. There's an excellent visualization online. This is actually taken from an animation showing the dog as the weather, variability, and the walker, the person who's walking here, is climate. Hansen and others have used dye and loaded dye to look at weather, the role, versus series of roles, climate. But to think about what those things are up front, and make sure you hit home on those 3 or 4 things during the course of your program. Next slide. In order to do that, sometimes it's important to think about how the visualizations you choose accurately portray information. And I think with the National Climate Assessment and some new documents, we've been doing a much better job of conveying this is precipitation. When we speak to the agricultural communities in Ohio, we talk about temperature and precipitation. And this is a very straightforward graph looking at heavy precipitation events. And you can see in the Midwest, they're up by 37%. So if you're going to hit home and address that, we found this to be a much easier way to convey that information than going ahead and providing a lot of very detailed graphs. This document, if you peruse these documents, there's also a lot of great graphs you can pull out that students can use to glean down into data sets without having to just give them raw data. Next slide. The next thing is how you want to convey the information, or how you want to communicate it so the audiences will understand. People's life experiences are very different. For a lot of the audiences that aren't in formal settings, the graphic on the left we found to be very helpful. Many people have taken vacation to Virginia. They've taken vacations to maybe Arkansas, Louisiana. And so discussing what the winter and summer temperatures look like in Ohio in terms of what the state would have to move to latitude-wise to have the expected experience in the future, it's easier than saying the temperature goes up by 2-3 degrees. People aren't able to see or don't have the experience to know that 2 or 3 degrees is a substantial increase. You could say, well, the last ice age was 8 degrees cooler than it is today, but they still don't have a good reference point. A graphic like the one on the left allows them to identify with something they're familiar with. For those of us in Ohio, anytime we talk about things like the state tree, the Buckeye, which is also the mascot for our state, that tends to pique people's interest. So the picture on the right is a discussion of, will the Buckeye tree still exist in Ohio in the future, or will it migrate to our rival state of Michigan? This got, more than any other topic we have about biology and climate change in the state, this seems to always come up again and again and again of the mascot moving north and leaving the state. Next slide. Something else to think about is the visualizations you work with. NOAA, NASA, and a lot of universities have gone to great lengths to present better visualization tools to look at data. This is an animation I would strongly encourage if you're looking at both the change over time and also geographic distribution of climate change impacts in the world. You can play this animation and it runs through from 1880 to current and where we've seen anomalies in the planet. The color changing is dramatic enough that it really impacts people's thinking about stuff. Next slide. Terminology is important, and realizing that the way you deliver information, the word choice you make, isn't always received by the audience the same way you hope it will be. There's been a lot of training that AGU has done in San Francisco with educators. This is from Somerville and Hassel. I think I pronounced the person's name correctly, but it was in actually a physics teacher journal looking at the terminology on the left, how the public interprets it, and how the scientists would mean to portray it. I actually had this experience when I went to India. You'll see the second from the bottom is scheme. And in India, government programs are called government schemes. So for the first 2 days when I was in India, I'd watch the news every night, and they continued to talk about the new government schemes that were going on and the officials that were discussing this. For those of us in the U.S., if you talk about a scheme, most people are thinking it's some kind of plot. Everyday language in India, it's just a government program. But you also have to think about in the scientific community, systematic plan. And so what are the words you might be using and thinking deliberately about how the audience interprets that. Things like positive trend, enhance, positive feedback are not going to be understood the same way you say them. You might want to consider your word choice carefully. Next slide. Local impacts, and I'll kind of start to close out stuff with this. We had a large algal bloom in Ohio, and the good thing is we were able to get out ahead of this. The Ohio State University and the Bird Center with some collaborators actually hosted a program spring of 2014, the spring before this event happened. In the audience, there were actually a lot of the news media that were understanding better what the climate change impacts were in Ohio, and the algal blooms were one of the points of discussion. That really helped us when this event happened in midsummer, and we had a large algal bloom that shut down a water supply for multiple days to a few 100,000 people. The news agency, one of the newspapers from the Toledo area was actually there, and the reporter had sat in on all the sessions. So they were well poised to know what was happening and who to speak to. This is also something that comes up again and again and again in Ohio. People are very attuned to climate change impacts related to algal blooms because we've seen this in the Ohio River, we're seeing this in our lakes, and we're also seeing it in Lake Erie. And it's a real concern for water supplies and local recreation. The next slide shows a similar picture. We had a freeway flood. We've had a number of big flooding events happen here due to torrential downpours. People seeing a freeway picture like this to an area that they've driven, it's never flooded, that we have a 1,000-year event, it's never flooded since the freeway's been built, also starts a better conversation about what are the costs to human infrastructure due to climate change. So what can you do as individuals? And that's what I'll leave everybody on this evening. And this is kind of the list of things I think you should consider with trying to educate others and also professionally advancing yourself, personally advancing yourself. Try to continue to seek and learn out as much as you can. The important part about that first bullet point is credible sources. How do you help people understand credible from non-credible sources? Realize there are some people you will never get to trust. Certain sources we know to be relatively credible. Universities, government agencies. There are some individuals that have conspiracy theories, and there's really not a lot you can do to dispel them one way or the other to change their thinking. It's not always wise to invest your time on those individuals. Consider candidates for office, what you vote for. What actions can you take with letters to the editor, attending public hearings, things you can do to make yourself more in tune between the election cycle. The fourth bullet point, financial decisions are really important, and I think for a lot of youth, it's easy, because we have a very consumerist society, to think about voting with your dollars. It's easy to know a lot about the companies that you purchase from now, and to make sure your dollars vote for the ones you want to contribute to because they have priorities that are in line with yours and your understanding about climate science. Build sustainable practices in your place of employment. There's a lot of things we've done in our own building here with renovations, trying to think more carefully about what we do. A lot of upfront costs, things that seem more expensive upfront, like LEDs, different infrastructure, actually saves you money over the long term, getting that conversation going about long-term costs rather than short-term costs. And the last, probably the most important bullet point is the U.S. has seen a lot of animosity and kind of political polarization about this. I think we're going to see a bit of a thaw here, and I say that for a lot of reasons. People we have come through and visit, things we see in the religious community in Columbus, and a lot of faith groups coming through in the conversations we have with them. But figure out how to have open and candid conversations, even with family, friends, community organizations that don't agree with you. There's a lot of seeds you plant, a lot of seeds you have been planting for the last 10 years that come to fruition over time. And I think a lot of those seeds that our own center sowed 5 and 10 years ago are coming back to reap benefits now as we're having a lot of people from across the political spectrum come in and learn more and refer others to us. So to be that trusted source that people know you'll have a candid conversation even if they don't agree with the science, it's important to do that. So with that, I'll close out and I'll entertain any questions that people have.
Gosh, thank you so much to both of you for your presentations. I think one of the last points you just made about conversation is one of the key pieces too, where we need to be open to kind of listening and sharing as much as we can in those spaces. That was really great. If there are any questions, they can be typed into the chat box, but also if you'd like to ask a question live, you can raise your hand in the participant panel. And if we see any of those, I will unmute your microphone so you can ask your question live if you'd like. We've got a couple people in the background making comments. It was great, really enjoyed it, especially the honesty about what we can do about getting youth to be involved. Did you want to comment any more on that, Jason?
I think that, there's so many things that depend on local context. There's really not a simple answer there. And I think there's not a simple answer over the course of a lot of environmental issues. We struggle in the city because a lot of the poor populations, maybe this is not a here and now issue, even though we know we had a climate assessment for the city of Columbus, we know poor populations in the city will be impacted the most. We've seen a lot of other suburban schools doing things that help out indirectly, like I mentioned some of the community gardens and those things that they're growing, going to food pantries, or some festival that ends up connecting sustainability, so larger themes in environmental issues, not just climate change. But I think it's trying to carve out something you can do on a local level, scale it up. I know hands-on practical projects, one of the successes I had in the classroom before I left is having students do an energy audit or an environmental audit for their own facility and looking at resources, we actually went through the trash and cafeteria and figured out what percentage could have been recycled. We had no pre-existing recycling program. We found out the school was actually crushing up the light bulbs, which had mercury in them, and throwing them out, which was actually illegal. We did an assessment of how much energy can be spent by just shutting down lights in certain parts of the building or putting motion sensors in. And as far as it was a remedial science class, getting data, producing a report, recommending the principal do X, Y, and Z because it saved money, and then putting that money forward to a few projects. Students had to present that information to a public audience. We actually had community members come in and give them feedback on it. It was very rewarding for them. But it took some time, and it would have really helped if we could figure out how to connect that to an English class or social studies class. So I don't have a lot of easy answers to that, because the more people you can involve, the more practical you can make it, the more local you can make it, the better.
Great.
If you think about the soft skills we want students to learn, communication, project management, all the employers that come through here say, we want students that show up, that can take projects from planning to fruition, they can communicate accurately, written and orally. Those are all the things that come up as soft skills they want to see.
Right, those transferable skills. That's a great point. I've got another question here, and forgive me if I don't quite get it correctly, but the question is how to answer questions by those questioning models. And I don't know, that might even be a question for Paolo as well. How do we answer questions by those questioning the models?
That's we actually have a whole modeling group here, and just trying to convey the work they do is challenging, because the amount of computer code, the amount of data, the amount of complexity. One of the things I've always referred to is climate models are kind of like video games. If you think about starting out with Atari, when you're in 2 dimensions, and then you get 3 dimensions, and how you can move, and we can render video games now that are very accurate, like movies almost, that you would think it was a movie that's filmed. Gives you a sense of the change that's happened with modeling with computers from the 60s onward, and how complicated they've become and how intensive they've become with analyzing data. Depends on the question you have. It's actually there's a long answer, and I think if I was going to answer that question, I'd probably want to speak to the person more about what questions they're getting. Exactly. Some people you're going to find out, one of the first things is to ask the person, so what evidence would it take for you to accept that climate change is happening? And if that person says there is none, I'm an ideologue, in other words, they say that, they're really not thinking scientifically. There's no real conversation you can have, because they're already set in their ways. And science is refutable. Inherently, it's refutable if you have data to the contrary. Beyond that, if there's some specific question they have, then it depends on what it is.
And yeah, if I can add something, Sarah.
Sure, please.
It is always important to remember that models are based on data. There are no models that are not that are developed without data. And with models, we are able to explain the climate of the past, the climate at present time, and this allow us to make projection and scenarios for the future. Of course, for predicting the future is much more complicated, because there are some variables that are not only linked to the physical system, but also to the society. Are we going, for instance, to run out of oil or not, and how long could it take? These are very difficult questions to answer. It depends on the resource in itself, on the technological development, and so on. But given that, we can certainly say that our models are able to explain the climate of the past and the present climate, and so we can have confidence in the scenarios that they can provide for the future.
A lot of times this comes up because people will say weather is the same as climate, So they look and say, well, the models you're using for the weather that are going to hit this area in 3 days aren't perfect, so therefore your models for climate must be the same. They're not, they have a lot of uncertainty. And I think there the conversation between weather and climate's maybe important to have as much as it is to talk about the model, because I think most people are ignorant to the models that are used everywhere in their life. The models are used in so many different places and are always being run in the background, but they have no knowledge of them. So this is somehow seen as very different.
Great.
If
Thank you.
person wants to let me follow up, I think we can send out kind of some analogies and maybe some ways you can start that conversation. There's a lot of people in the climate ed community trying to figure out better ways to convey that, because the new national science standards, NGSS, mentions climate models a lot, and at different age levels they mean different things. And it's not always easy in the classroom, even with high school students, to know where do you put data. And models don't always have to be complex. Computer models, they can be simpler, linear models to allow us to forecast things.
Absolutely. That's a great point about bringing it into the national standards, because it is a big piece of that. Well, I think that we'll have to wrap up here on the hour. I wanted to say thank you to our presenters for sharing with us their work. It's always a real benefit to both communities to hear the science and the communication sides of issues that we're looking at in polar sciences. And so that's one of the big goals of Polar Educators International, is to bring together our different communities to share sort of a common bond or common language to best be able to share polar education and research to a global community. So I appreciate everybody attending, and the archive should be available shortly. It'll be available on the Polar Educators International website, and we'll send it to all the folks who have registered for the events. Again, for the certificate of participation, folks who are signed up for that, you have about 10 days or so, and after the webinars, to host a discussion on your own about the content, and then supply basically a one-page summary of those discussions that were had, so that we know that folks were following up. And if you're interested in having a masterclass international with a different set of countries, Italy and the United States took it upon themselves to begin this global conversation, and we're interested in hosting these events for other countries across the world. So please let us know if you'd be interested in that. So with that, again, I'll say thank you so much to our speakers today and on Tuesday in Italian. It was a wonderful turnout for both events, and we look forward to the future. Thanks so much for joining us.
Thank you.
Thank you.